spectrum. Hydrogen okay. Now, first of all, we should know what is spectrum. See, when we allow the light to pass through a prism, then you'll find we know that visible light or sunlight consists of 7 colors that you have observed in even rainbow. But all these colors are merged with each other, so distinctly you cannot see all the colors. Now, if you allow the light to go through a prism, or if it undergoes diffraction, then all the 7 colors you will see it clearly. So this is known as spectra. All right. The splitting of a beam of light into radiations of different wavelengths or frequencies after passing through a prism or diffraction grating. This is an instrument. Is called dispersion. And the pattern of radiation observed is called after dispersion is called the instrument used to separate radiations of different frequencies of is termed spectroscope. This is the machine. Depending on the source of radiation, of different wavelengths. Sorry, depending on the source of radiations, the spectra are are broadly classified as into one, emission spectrum, emission spectra, second one is absorption spectrum. So we'll try to know what is emission spectrum and what is absorption. See, what is emission spectrum? Suppose you have heated a substance, and after heating, when you start cooling it, then you find the hot substance, then it radiates the energy, and that energy or light that is passed through a prism, whatever the spectrum that you get, we call it emission spectrum. So emission spectrum. Emission spectrum. Say you can suppose you at home you are using heater. The coil has become red. That if that or yellow, if it's allowed to go through a prism, then you'll find it will several colors it is going to show. That is called the emission spectrum. When light emitted by self-luminous object is dispersed by a prism, you get spectrum known as emission spectrum. Self-luminous means what? Suppose a bulb. Allow this light of the bulb to go through a prism, you'll find it is break down into several colors. So that is nothing but an emission spectrum. It can be of three types. Okay? One. Okay, let me write here this, let me write here capital A, and here I'll write small. So capital A, capital A. I'll write now here. Continuous spectrum. That is the rainbow. Within rainbow, that is 7 colors that you see. They are not separated from each other. One is overlapping with the other. So rainbow is an example of continuous spectrum. All right. When white light, that is called visible light, is allowed to pass through a prism, it gets resolved into several colors. Okay, you can write here with your where the colors are merged with one another. Such spectrum is known as continuous spectrum. Example क्या है? Just I given you rainbow. B. Discontinuous spectrum. What is discontinuous spectrum? So you'll find between the different colors, a gap is there. And that will a gap will come as a black band. This is called discontinuous spectrum. When gases or vapors, gases and vapors are not same. The substance which is remains liquid at room temperature, if you convert them to gaseous state, that you call vapor. Like water vapor, ethanol vapor. But carbon dioxide, nitrogen, oxygen are gases, because even at room temperature also they are not in the liquid form. So when gases or vapors of chemical substances are heated in an electric arc, you have to heat it at very high temperature, or Bunsen flame. Bunsen means that the flame is being created by burning of gas. If you go to laboratory, you will be using Bunsen burner. Bunsen flame, light is emitted. If the ray of light is passed through a prism, line spectrum is produced. These are separated from each other by dark spaces. Each line separated each line corresponds to a different wavelength or frequency. The line spectrum is also known as atomic spectra. एग्जाम्पल क्या है? हाइड्रोजन स्पेक्ट्रम. So how to show you? My pen is black now. How to show? Okay, I'll draw a small one. Huh? So this is the plate. Huh? So we'll find, say, this is the black space. This is the line. And this line will be bright, okay, of different colors. All right. And these are the spaces by which you will find. In fact, it will not be like this because sharp line will be there. So much of space will not be there. Okay. So I'll draw something, huh? Whatever I write, you think otherwise. Say it is like this. The places where I'm drawing the dark line, in fact, they are not black. The white portions are black. And these are this where you find different colors will be there. The different colors will be there, and white portion is black. Just like that, these days we are taking all digital photograph. If you go to studio and take photograph, in that case they will give you a negative. You will find your hair looks white, but actually it is dark. So this is the thing you're going to see. Now we'll go for band spectrum. So emission spectrum of three types. These are continuous spectrum. Example is a rainbow. Discontinuous spectrum, where you will find if you go take some atom or molecule, you can take an atom, okay, and if you heat it by an electric arc or by Bunsen flame, the substance will radiate something, and if that radiation is allowed to pass through prism or diffraction grating meter, in that case you'll find it is going to show you some sharp line, but these lines are separated by some dark spaces. So these are called line spectrum. Example is hydrogen. Then we have band spectrum. In band spectrum, you'll find the lines are not appearing. Just like initially I have drawn, na? So you'll find that it is like this. Other places are there. Oh, so you'll find it is not line, but it is thick. Okay, so these are called band spectrum. So band spectrum are generally shown by molecules. It consists of bright bands. separated from each other by dark spaces. These are produced by excited molecules. Okay, we'll get now here band spectrum. In fact, band spectrum consists of several line spectra. So now we'll go for absorption. See, so this is a source. Okay, this is this one. That it is coming out. If you put a prism, you'll find in the screen, you'll find this type of lights are being separate. Okay, you like this is called emission spectrum. Now, same thing is there. All right. Now, you have allowed this one to pass through a medium, and after that you have put a prism. In this case, same way thing will come. This is called emission spectrum. This is called absorption spectrum. Why? Because here we are analyzing the refracted light. The light has gone through the prism. Some amount of light is being absorbed by the medium. Rest of them has come out. And this one, if you resolve it with the help of prism, whatever the spectrum that you get is called band spectrum. Sorry, absorption spectrum. Absorption spectrum. Clear? When white light having all the wavelengths of visible region is passed through a medium and the transmitted means what? Reflected only. Is dispersed by a prism few dark lines or bands are obtained. in the otherwise continuous spectrum. Why these dark lines are appearing? Because these are being absorbed by the media. Okay, this is known as absorption spectrum. See, absorption spectrum is just opposite of the emission spectrum. Wherever in emission spectrum, wherever the light will be there, in absorption spectrum, that place light will not be there. Wherever dark lines are there in dark space is there in case of the absorption spectra, in emission spectrum, in those places absorption you will find the light is there. It's just opposite of the emission spectrum. All right.
Sir, can you dictate after few dark lines, sir?
Or bands. Few dark lines or bands are obtained in the otherwise continuous spectrum.
Sir, after visible, what you wrote, sir, in second line?
When white light having all the wavelengths of visible region is passed through.
Sir, pardon? Sir, after visible?
Visible region is passed through a medium.
Sir, region spelling, sir?
REGION, region, is passed through a medium and the transmitted light is dispersed by a prism. Comma. Few dark lines or bands are obtained in the otherwise continuous spectrum. This is known as absorption spectrum. Okay, now we'll go for line spectrum of hydrogen. Line spectrum of hydrogen. When electric discharge, don't get scared by these words. It is if you send a high voltage to hydrogen gas, when electric discharge is passed through hydrogen gas, the H2 molecules dissociate, that is they break down into atom. H2 molecules dissociate and the energetically excited hydrogen atom, atoms produced. It is hydrogen molecules breaks down. Hydrogen atom produced emit electromagnetic radiation of discrete means fixed. Discrete means fixed. Radiations of discrete. Some of the words you should know. Frequencies. The hydrogen spectrum consists of several series of lines. Named after their discoverers. I'll write down the name, dear. Then I'll put the diagram and write there also. Okay. So these are the spectral lines. Discoverers. Who has discovered? And the region in which appear. Okay. So first one is Lyman series. So discovered by Lyman. Appears in ultraviolet region. We should, in short form, we call it UV. Second one is called Balmer. L is silent. L is silent. Balmer series. It is being discovered by Balmer. Appears in visible region. Visible region. So this is the line first discovered. Because those days, ultraviolet spectroscope was not there. So this is the first line discovered by Balmer. Balmer was the first person who had discovered hydrogen spectra or observed hydrogen spectra. Third, Question series. It is discovered by Question. It is found in infrared region. 4 bracket BRECKE no bra BRA yes BR let me see spelling I think it is BRE.
So what's the third?
Third one is Paschen, PASCHEN, Paschen series. BRACKET bracket series. So it is discovered by bracket. This is also found in infrared region. 5. PFUND. So its pronunciation is fund. P is silent. Fund series. Okay. PF. Don't call it fund. Fund series. This is also found in infrared region. But after that, in your book, they have not mentioned, but one more series is there. I'm going to write it for your entrance exam. Okay, it's called Humphrey series. Humphrey series. This is discovered by Humphrey. This is found in far infrared region. Let me put some ink.
Sir, number 6, Humphrey spelling, sir.
HUMPHREY. So this is not in your book. Okay. So now I will draw its hydrogen spectrum and label it there. Okay. You can draw it scale, huh? Oh, sorry. Sorry, dear. So this is Lyman series. This is Balmer series. This is Bastian series. This is bracket. This is Fund series. Humphrey series. Draw. So once you finish, you tell me.
Done, sir.
So this is the one that suppose you have taken the spectra and you have put photographic plate, you'll find this type of lines are appearing. Okay, first observed is this one, Balmer series, and on the basis of that he has given an equation. All right, but later on when all other series are being found, it is found that it can be given by a general equation. Okay, so this general equation given, so hydrogen spectrum can be explained by a, see, this is called wave number. I told you the inverse of wavelength is called wave number, is equal to nu frequency. These are the frequencies. Okay, equal to R1 N1 square minus N2 square. Never get scared, huh? N2 square, where N2 is greater than N1. All right, N2 is greater than. So if N is this is the first cell, then N2 can be second, third, fourth, fifth, sixth, seventh, eighth. If N2 is for Balmer, he has found it for what? Up to the second level. So if N1, if N1 is equal to N2, then N2 will be 3, 4, 5, 6, 7, 8. Like this. All right. Now, what is this? N1 and N2 are the levels. And R is called Rydberg constant. Is equal to 109,677. Okay, sometimes we write R and sometimes we write RH also. So we can write here R or RH. Right. And N1 and N2 are the levels. All right. So please write down. So we can write down here 1 minus lambda is also called wave number. And wave number is indicated by not nu dear, nu bar. So we can write down here nu bar is equal to 1 minus 1 by lambda is equal to wave number. Okay. So let me write down here. In this case, what? In this case, N1, after that is diagram itself will write. N1 is equal to 1 and N2 is equal to 2, 3, 4, 5 like this. So for Lyman series, N1 is 1 and N2 is this. For Balmer series, N1 is 2 and N2 is equal to 3, 4, 5, 7, 6 like this. For Paston series, N1 is equal to 3. And N2 is equal to 4, 5, 6, 7. I have not drawn other lines also. There will be numerous lines. For bracket series, N1 is 4 and N2 is equal to 5, 6, 7, 8 lines. 8 line, I have not, 8 line is there. For font series, N1 is equal to 5, N2 is equal to 6, 7, 8 lines. And for Humphrey series, N1 is 6 and N2 is 7, 8, 9. Tell me when you finish, eh?
Done.
Okay. Okay, now see, in this case, there is a concept called last line. Last line is that one where from the last frequency is coming. Okay, the last frequency is coming. This is called last line, and it is having the highest energy. So in this case, Lyman series, what is the last line? This is the last. In this case, Lyman series, what is the last line? This is the last line. Okay. Now, my question is that how to remember the series? Lyman, Balmer, Bastian, Brackett, Fund, and Humphreys, because Humphrey is not there in your book. So you need not, but you should know that if in entrance exam they ask that how many lines are observed in hydrogen spectrum, then you have to say 6, because they'll give you option. Okay, actually it is see, Lyman, Balmer, Bastian, Brackett, Fund. It is up to this much is in your book, but one more is there in the infrared, far infrared, Humphrey. Which one appears where? Lyman appears in ultraviolet region, and the Balmer appears in visible region. Then Bastian, Brackett, and Fund appears in infrared region, and Humphrey series appears in far infrared region. All right. Now, so let me write down here Lyman, then Balmer, then Bastian, then what? Bracket, then Pund and Humphrey. Okay, so for time being there, I'll bring it here. Okay, how to remember the series, the sequence of the series. So I'll write it like this. You may laugh, but for remembering, I can do anything. Can you remember now? These words, though, we are very common in our houses. Some of your family member may suffer from low blood pressure, someone may suffer from high blood pressure. So is it not these words are common to you? These words are common to you or not?
Yes, sir.
Yes, sir.
So you write like this: LBP, HBP. After that, this H you shift to the right hand side. So this is for what? This is Baba. I remember like this. Sometimes you may forget also. Though now these days we are frequently teaching, so I for me I may not forget, but still with age also I may forget. So I remember like this. This one I'll shift. Okay. So this goes here. So now I'll write here now. Okay, I write down here Humphrey. I'll shift it here. All right. And this one is, if you wish, you can write. Otherwise, you forget. So I now will give you a formula which is very important for your entrance exam. See, you have seen so many lines are there, na? So many lines are there. See, they are dropping from different levels and falling down. So several lines are there. They may ask you, they will tell you. That is, the electron from lower level, it goes to the 6th level. How many lines is going to appear? Then in that case, you to draw then. In entrance exam, can you draw such a big diagram and calculate? So I'll give you this formula. This formula is not that dear. I'm extraordinary. No, because I had been teaching entrance exam for last 15, 16 years. So I come across several questions, and most of the books, they have not given this simple formula of calculation. Luckily, I got in one of the books, so I have written down. So I'll write down here. Mathematical formulation for calculation of number of lines in spectrum. So it is not difficult. All right. It is N2 minus N1, then N2 minus N1 plus 1 divided by 2. It is not at all difficult. I told you it is coming from 6th line to 1st line. So how many lines are there? So here N2 is equal to 6 and N1 is equal to 1. So what should I write now here? It is 6 minus 1, 6 minus 1 plus 1 divided by. How much it comes? 5 into 6 divided by 2. So 50. So this is the way we calculate. Okay? This is not going to be asked in any of your board exam, but this may be asked in your entrance exam. And if you come across such questions, I believe you will be able to answer it, and I shall be very, very great. Very, very grateful to you.
Done, sir.
Okay? So rest I'll discuss tomorrow.